Right, this is 0620 October November 2019, paper 4, variant 2. Question number 1. The periodic table is very useful to chemists. Refer only to the elements with atomic number 1 to 36 in periodic table provided when answering question 1. A. Part 1. Use the information from periodic table provided to identify one element which has atoms with exactly 9 protons. So the element with atomic number 9, which is also equal to the number of protons, is fluorine. So the answer for part 1 is fluorine. Part 2 has atoms with 0 neutrons. Alright, so this is hydrogen since it only has one proton in its nucleus, and so it does not need any neutron to keep protons from repelling from each other. Part 3 has atoms with 23 electrons, so the element with atomic number 23 is vanadium. Part 4 has atoms with an electronic structure of 286. So this gives us the atomic number 16, which is sulfur. Part 5 forms ions with a charge of 3 minus containing 18 electrons. Alright, so this means the actual number of electrons is 3 less than 18, which is 15. So the element in the periodic table with the atomic number 15 is phosphorus. Part 6 forms ions with a charge of 2 plus containing 10 electrons. Now this means that this ion originally has 12 electrons. Since over here this has a charge of 2 plus, so we need to add 2 more electrons to make it a neutral atom. And the element with an atomic number of 12 is magnesium. Alright, part 7 has a relative atomic mass that shows it has at least 2 isotopes. This is chlorine because chlorine does not have a whole number figure of its atomic mass. B. State which metal in the first 36 elements 1 is the group 1 element which reacts most vigorously with water. Alright, so this is potassium because in group 1 the reactivity increases as we go down the group. So lithium is the least reactive metal with the reactivity increasing as we go down from lithium to sodium to potassium, and the rest 3 elements in first group are not normally found in laboratories, so we consider potassium being the most reactive. Part 2 reacts with air to form lime. Lime is calcium oxide, so this is calcium. C. The one element in the first 36 elements is used as the fuel in a fuel cell. Name this element. So this is hydrogen. Part 2. Write the overall chemical equation for the reaction which occurs when the element in C1 reacts in a fuel cell. Alright, so in a fuel cell, hydrogen burns and the only product is water. So this is quite a simple equation. So we have hydrogen which reacts with oxygen forming water as the only product. Now we need to equate this equation. So we have 2 oxygen atoms on the product side as well as on the reactant side, but since there is 4 atoms of hydrogen over the product side, we also need to equate it on the reactant side, which gives us an equal equation, a balanced equation. Question number 2. The gases argon, carbon dioxide, nitrogen and oxygen are in clean, dry air. Carbon monoxide, nitrogen monoxide, nitrogen dioxide and sulfur dioxide are gases commonly found in polluted air. What percentage of clean, dry air is nitrogen gas? Give your answer in the nearest whole number. Alright. So the percentage is 78. B. Name the process used to separate oxygen from clean dry air. So this is a fractional distillation of liquid air. The way that we do this is that we boil all of the gases, nitrogen, oxygen, argon, and then we let it condense. So the gases then condense in separate chambers according to their boiling points. Part C. State one major adverse effect of the pollutant sulfur dioxide. This is acidic rain. And this happens when sulfur dioxide in the air dissolves into the rainwater, resulting in the formation of sulfuric acid H2SO4, which causes acidic rain. Part D. Nitrogen monoxide and nitrogen dioxide are produced in car engines. Describe how oxides of nitrogen form in a car engine. Right, so nitrogen and oxygen do not normally react, but they do in carbon engines because of the high temperatures. So nitrogen Alright. E. Many cars have catalytic converters in their exhaust systems. In a catalytic converter, most of the carbon monoxide and nitrogen monoxide formed in a carbon engine is changed into less harmful products. Identify these products and state the metal catalyst used. Alright, so the products are carbon dioxide and nitrogen, which are far less harmful than carbon monoxide and nitrogen monoxide. And the catalyst used is platinum. Alright, F. Carbon monoxide is formed from the incomplete combustion of fossil fuels such as methane. Write a chemical equation to show the incomplete combustion of methane. Alright, so methane is CH4. CH4. It reacts with oxygen, giving carbon monoxide due to incomplete combustion along with water. Alright, so to balance this equation, we have 4 hydrogen atoms on the reactant side. So let's equate it on the product side as well. And here we have 3 oxygen atoms. Right, so we can equate this by writing 1.5 on the reactant side of oxygen, which gives us 2 times 1.5, the answer of 3. Alright, so the number of carbon, hydrogen and oxygen atoms are both balanced, all balanced on both sides of the equation. G. The carbon dioxide in air is part of the carbon cycle. The scheme shows a simple representation of part of the carbon cycle. Part 1. State the scientific terms for each of the process A and process B. So process A is when carbon dioxide in the air is converted to glucose found in green plants. This is quite simple by photosynthesis. And B is when animals, alright, so glucose ingested by animals is converted to carbon dioxide in the air is respiration. Part 2. Plants convert glucose into complex carbohydrates. A unit of glucose can be represented as shown. Complete the diagram to show the complex carbohydrate formed from 3 units of glucose. Show all of the atoms and all of the bonds and the linkages. Right, so what happens here is that a hydrogen atom from one side is excluded along with both of hydrogen and oxygen atoms from the other side. So each of these monomers is left with only a single oxygen atom at either of the sides, which also results in the formation of water, H2O. So we have, let's suppose O from here. Alright, oxygen from the right hand side is left in all 3 of these monomers. That's it. Part 2. Complex carbohydrates break down to form simple sugars. State 2 ways that complex carbohydrates can be broken down into simple sugars. Right, so there's only the usage of enzymes or acids. Right, part 5. Name a suitable technique for separating and identifying the individual sugars formed when complex carbohydrates are broken. So the only way for us to identify them and separate them is using chromatography. Because all of them are going to be soluble in water. Okay, moving on to question number 3. Ammonia is an important chemical. Ammonia is manufactured by the Haber process. The reaction is reversible. What is the sign of a reversible reaction? Alright, so this is a double-headed arrow. Okay, that's it. State the essential conditions for the manufacture of ammonia by the Haber process, starting from hydrogen and nitrogen. Include a chemical equation to show the reaction which occurs. And so this is quite simple. We only have to mention the catalyst, pressure and temperature along with the balanced equation. At 450 degrees Celsius and catalyst of iron beds. Right, so these are the conditions required, and then we're supposed to write the chemical equation. Okay, so we have the equation as nitrogen reacting with hydrogen giving us ammonia. Alright, so we need to write the double-headed arrows and balance it, as there is 2 nitrogen atoms and then 6 hydrogen atoms. Alright, so this is our balanced equation. Part 2, name one raw material which is a source of the hydrogen used in the Haber process. This can be methane. B1, ammonia is a base and reacts with sulfuric acid to form salt. From the salt ammonium sulfate. What is meant by the term base? It is a proton acceptor. Part 2, name the industrial process used to manufacture sulfuric acid. This is the contact process. Alright, part 3, write a chemical equation for the reaction between ammonia and sulfuric acid. Alright, so we have ammonia as NH3 with our sulfuric acid H2SO4. Alright, now to form the formula of the compound, we need to let's write the ions over here. We have ammonium ion with charge of +1 and the sulfate ion. So this is the sulfate ion over here, the charge of -2. And writing the valency over here, we're going to have to cross these valencies with the ions. So this gives us 2 ammonium ions along with 1 sulfate ion. And the reason for this is that we need 2 positive ammonium ions to cancel the charge of 2 negative sulfate ion, a single ion with a charge of -2. Right, so we have our compound as NH4 2 and SO4. That's it. And then we're going to have to balance it by writing a 2 over here. So 2 nitrogen atoms and 6 plus 2, 8 hydrogen atoms on both of the sides and the sulfate ion. Alright, that's it. Part C. When aqueous ammonia is added to aqueous iron 2 sulfate, a green precipitate is seen. The green precipitate turns red-brown at the surface. Right. Name the green precipitate. This is iron 2 hydroxide. Part 2, suggest why the green precipitate turns red-brown at the surface. Alright, so iron 2 on the surface reacts with oxygen and it loses 1 electron and then is oxidized to iron 3 oxide. So iron Alright, part 3, state what happens when an excess of aqueous ammonia is added to the green precipitate. So the green precipitate does not react, no change occurs, so it remains the same. Because the precipitate over here, iron 3 hydroxide, is insoluble in ammonia. Okay, moving on to part D. Ammonia reacts with oxygen as shown. So we have 4 moles of ammonia reacting with 5 moles of ammonia and forming ammonium nitrogen monoxide with water. Okay, calculate the volume of oxygen at room temperature and pressure in dm cube that reacts with 4.8 dm cube of ammonia. Alright, so in order for us to calculate the volume of oxygen, we need to have the molar volume and the number of moles of oxygen. Now we can find the number of moles of oxygen by using this equation, and this is how we do it. Right. So we have 4 moles of ammonia reacting with 5 moles of oxygen. Right. Now for 4.8 dm cube of ammonia, we need to find out the number of moles of ammonia so that we can deduce the number of moles of oxygen. So moles over here is volume over molar volume, which is 4.8 divided by 24 dm cube, and this gives us the number of moles of 0.2 moles. Right, so 0.2 moles. Now we're going to have to use cross multiplication over here. So 0.2 moles are going to have to give us, we're going to have to multiply 0.2 with 5, and the answer is 1, and then when we divide it by 4, we get the answer as 0.25 moles of oxygen. Now when we have the number of moles of oxygen, we can find out the volume, which is number of moles into the molar volume. So this is 0.25 into 24, which gives us the volume of 6 dm cube. Alright, here we have the volume. Part 2. The chemical equation for the reaction can be represented as shown. Use the bond energies in the table to calculate the energy change in kilojoules per mole, which occurs when 1 mole of nitrogen ammonia reacts. Alright, so over here we have 4 moles of ammonia, but the question asks us to find the energy in the case when 1 mole of ammonia reacts. So first off, we're going to have to find the number of moles of other substances which react and are formed with only 1 mole of ammonia. Alright, we can do over here we can do cross multiplication again. So when 4 moles of ammonium react with 5 moles of oxygen, how many moles of oxygen react with 1 mole of ammonia? So this is quite simple. We multiply 5 with 1 and then divide the answer by 4, which gives us 1.25 moles of oxygen. I'm gonna write it over here, so this makes it simple for us. Right, 1.25 moles of oxygen react with 1 mole of hydrogen. And then we have alright, so the number of moles in the equation, in the question we have the same number of moles of ammonia and nitrogen monoxide, which means 4 moles of ammonia gives 4 moles of nitrogen monoxide, so 1 mole would give 1 mole of nitrogen monoxide. Now we're going to have to cross multiply to find out the number of moles of water. So 4 moles of ammonia gives 6 moles of water. How many moles are given by 1 mole of ammonia? Right, so we multiply 6 with 1 and then we divide the answer by 4, which gives us 1.5 moles of water. Alright, so we have the number of moles in the equation over here. So energy needed to break bonds. Now breaking bonds, alright, so bonds are broken on the reactant hand side, so we need to figure out the the energy on the reactant side. So in ammonia we have 3 bonds of nitrogen with hydrogen, and each of these single bond requires 391 kilojoules per mole to be broken. So we multiply 391 with 3 because we have 3 bonds of these, and then we're going to have to add the oxygen bonds, which is 498. Right, in this case when there is only 1 mole of ammonia, we have 1.25 moles of ammonia. So we're going to have to multiply this 4.498 with 1.25. Right, now when we add these, we get the energy as 1795.5. Right, so this is the amount of energy needed to break bonds when we have 1 mole of ammonia reacting with 1 mole of 1.225 moles of oxygen. Now energy released when bonds are formed, this is the energy released on the product hand side. So we have only 1 mole of nitrogen monoxide, and this has the energy of 587. So we had 587 with the energy of 1.5 moles of water. So here we have 2 moles of 2 bonds between hydrogen and oxygen. So first we're going to have to multiply 2 with the energy of a single bond, which is 464, and then we multiply this whole answer with 1.5 because we have a total of 1.5 moles of water over here. Okay, right, so when we add these, we get our answer as 1979 kilojoule per mole. So this is the energy given out when the reaction occurs. Right, energy change when 1 mole of ammonia reacts. So we're going to have to subtract the energy required. We're going to have to subtract the energy given out from the energy required, which is the energy on the product side subtracted from the energy on the reactant side. And this gives us the answer of negative 183.5 kilojoules per mole. Alright, so we have our answer over here. Got to put the negative sign over here. Alright, so we're done with this question.